Okay, so today we're going to talk about projectile motion and some concepts that should be known about projectile motion. So first, something important to know about projectile motion is that you're always going to have, or almost always, you're going to have a value called g. And g can also be called a, or the acceleration. However, we call it g because g stands for gravity. And this value is negative 10 meters per second squared in our case. So this value is going to be very important. Negative 10 meters per second squared is g, or the vector acceleration. So now we can look at our question and see how we're going to use g. So first, let's start by drawing out a graph so it may be easier to visualize. So here we have a Here we have a value r0. Here we have a value v0. And this is the initial points of the projectile motion that was given. But there are two other values here that are Vx and Vy. Now, it's important to note that R0, or R initial, or the initial position of the ball or the object, can be parallel to V0. So this point can be parallel with this amount, or it can be anti-parallel. So they can be parallel or they cannot be parallel. Those two values, R0, or the initial position, and the V0, or the initial velocity. Now we can talk about these values here. So the x components of the graph of velocity are always constant. So Vx, this vector here in yellow, is always constant. That amount is the same throughout the trajectory, throughout the projectile motion. But the Vy, or the y components of the graph and of this projectile motion, are always changing. These values here in blue, the v of y is always changing. That value and the amount is always changing due to the g being negative 10 meters per second, so it's always maybe decreasing, and also because of the velocity overall in the y direction. Here, there's nothing affecting the v of x, but the v of y is being affected by the value g, or the acceleration that is happening in the negative 10 j direction, or in the x values are going down. So now that we know that, we can go and try to see some equations using using v of t, x of t, and y of t. So let's just draw what we had before. Okay. So let's look at how we can find the equation for v of t. So v of t is the velocity. And you can find the v values. Let's say we draw out the vectors. This is v0, or the initial velocity, and this is v final, or the final velocity. So this would be the change in the velocity, this vector here. And we can use this diagram to write an equation for velocity, or the change in velocity. So using this, these vectors and this triangle that was formed, we can say that delta v is equal to a, the vector a, or acceleration, times delta t. Now we know what a is. We know what the acceleration is. So let's plug it in. Delta v is equal to -10 times delta t in the j direction. Negative and j. Negative and j. That signifies that you're going down 10 in the x direction, or j. So now that we have that, we can move on to see if we can find any equation or formula for x of t. So the equation for x of t is going to be very simple because, as we said, it's always constant. So x of t is similar to r0, or the initial position. So since the x values are always constant, the equation is x0, or the initial position, plus v0x times t. This is the equation for x of t, given that we know that the x values are always constant. Now we can move on to find the value, or the equation for y of t. Now this one is a little bit more complex, just because we know that the y components of the projectile motion is always changing. So since we know that it's always changing, you need to use the equation y of 0 plus v0y plus t times t minus 1/2 g t squared. Now, why do we use this equation? Let me write it again. We use this equation that I just wrote because we know that the y components of projectile motion are always changing. So, y of t equals y0 plus v0y times t minus 1/2 gt squared. Now this, you may know already, is the equation for constant acceleration. And that is why we use this equation, because we have constant acceleration, as we said before. The constant acceleration is equal to g, which is equal to -10 meters per second squared. So since we have acceleration in the y values, we need to use this equation to signify that. So now that we know this, now that we know some basic concepts about projectile motion, we can go to do an example. So this example gives us 5 initial conditions. So these conditions are x0 equals 0, y0 equals 100, v0x equals 50 meters per second, and also v0y equals 50 meters per second, and g, we know g, negative 10 meters per second squared. So these are the 5 initial conditions that were given about this problem about projectile motion. So now that we know these initial conditions, we can move on to find the answers to the questions being asked. So first, they want us to find the vector velocity. And the vector velocity is very easy. It's given in the initial conditions. It's 50 meters per second. So we found the vector velocity. Now they're asking us to find x of t. This is also very easy because x of t is, x initial plus v0x times t. X initial, we know from our initial conditions, is 0, plus v0x, we know that that's 50 times t. So the x of t equals 50t. So now that we found x of t, we can go on to find y of t, which is the next question. They want us to find the equation for y of t. So y of t, now this one is 100 plus 50t minus 5t squared. This is the equation for y of t. Now we know what 100 was. 100 is y0. We know 50. 50 is v0y. T is t, and we know 5. 5 came from dividing 1/2 by 10. 10 was our g value, and 1/2, you use this equation when you have constant acceleration. And since we said that the y values or the y components are what has constant change or constant acceleration, we use this this equation. Now we can find v of x, which is 50, and vy, which is 50 minus 10t. So now we found all the components of projectile motion, and we were able to see some important concepts.